data or your experiments may not, get a wider traction. So when you're doing anything, if you're performing organic synthesis, inorganic synthesis, you're working on semiconductors, you're working on wastewater treatment, it's important and you need to justify why that problem is worth solving, because ultimately you are the best advocate of your own work. Additionally, once you have written up a manuscript, you need to share your experimental details with another researcher if you want, because they are better placed to find out holes in it. Because you have worked on that manuscript for 6 months, 8 months, it becomes difficult for you to identify any lacunas or drawbacks in the study that you have designed. So it's always a good practice that even before peer review, reach out to your friends, your colleagues to understand that, yes, this is the experiments that I've done. Can you help me identify if there are any drawbacks in the study, or can I do additional experiments to make this better? Additionally, when you are writing a manuscript, you have a central theme, you have done a lot of experiments, you have identified that the data is complete, then that data needs to be analyzed accurately and objectively. Because every data has a story to tell, has like a background, has like a context. So when you come up with that data, you need to identify that why that data is behaving in a certain point. If your values are reducing, if the trend line is, tending towards closer towards zero, if the delta is tending closer towards a negative, you need to identify why that is happening. And then again, if it's happening and that phenomena has also been reported in other studies, you need to give a reference for that. And additionally, when you have done all that work, finally, you need to come and provide a very strong conclusion. And that conclusion needs to be a discussion of your work. And then again, also a justification that how your work in the manuscript is moving the field forward. So, given that writing a manuscript or preparing a manuscript is a vast undertaking, there are a very few steps, that go into, these are some of the steps that go into drafting a good quality manuscript. So the first step, in writing any manuscript is gathering data. You need to gather a lot of experimental data that you do, because if you're doing an experimental study, you need to have data. After having the data, you need to ask questions. Why? What? How? Why is that type of data coming? What are the phenomena influencing that? How do those phenomena or how do those lab conditions influence my data? After that, you need to organize your data by importance. And this is where a lot of people miss out. They organize their data by chronology. That I performed my experiment first, so I'll put this experiment first, and then again, I got this experimental data second, so I'll put it here. No, you need to organize the data by chronology. If you're performing synthesis, characterization, and application, the first thing that needs to come in a manuscript is the synthesis part, not the application part, right? So that is why when you are writing a manuscript, you need to organize your data by importance. One of the most important skill sets when you are writing a manuscript is to know that when and where a certain image or a certain data set needs to go. And this takes a lot of time. So you need, when you are preparing the framework of a manuscript, try to have an understanding that where you're going to put a certain amount of data, where you're going to put a certain figure. And trust me, it takes a lot of effort. It's going to take a lot of tries. But once you have that understanding, it's going to make a manuscript very good quality. Always a good practice to reach out to your friends or colleagues to understand that, yes, this is something that I've done. And then again, you can have additional outlines to see that if you have missed anything, can that also be added? And one of the key skills that one of the key drawbacks that I see in a lot of people, and that also used to happen with me, is that you don't need to wait to the very end to start writing a manuscript. That you cannot say that I'm still working on my experiments, that once the experiments are done, I'll start writing. No, you can start writing the manuscript as and when it is possible, and you can keep doing your experiments and simultaneously keep writing a manuscript, because materials and methods section, you don't need any additional information, right? You're doing the experiment, you can write the materials and methods section concurrently with your manuscript. So when we look at a manuscript, there is a structure to that. And the first thing that appears to is a title, after that an abstract, then again you have introduction, you have some data, you have the experimental section, you have the results and conclusion, the references, and the acknowledgement section. And this is how they are appearing on a paper, right? So the very first thing that comes before your eyes is a title. And if your manuscript has an effective title, it's going to become much more easier for you to have your manuscript sent out to peer review, right? But what makes a good quality title, or what makes a strong title? So a strong title is something that is small, it's not more than 20 words, and it's grammatically sound. You cannot have a title that's not making any sense in the colloquial languages, right? Another thing is that you need to avoid strong action words and avoid any type of adjectives or other jargons that make your title sound out of the world. Make your title should also reflect with your art experimental abstract, the graphical abstract, and it should not be something that is on a very different track than what your graphical abstract is showing. Additionally, you need to avoid buzzwords and acronyms and abbreviations. And finally, your title should not have potentially unjustified applications. So a lot of people get into this habit that I have prepared a chemical and it's going to solve all the water treatment problems in the world, or it's going to solve all the food pollution problems in the world. So no, you cannot make like a very hard to justify claims. Additionally, it's also important that when you're writing a title, you avoid the use of words like convenient, efficient, elegant, expedite, facile, because these things, they are not very, they're already self-understood. Because if you're doing a work, it's self-understood that it's novel, it's first time, it's convenient, it's expeditious. So you can avoid these type of words because you have very limited words. You just have 20 words, right? So try to avoid having these words. Additionally, if you want, you can just keep putting your questions in the chat box, and I can take them up once this part of the talk is lit. So coming back to a title, what are some of the key questions to ask when you're writing a title? So first and foremost, you need to have an understanding who is going to read the title. The very first person who is going to read your title is the editor-in-chief of the manuscript of the journal in which you submit your manuscript. So it should be designed in such a way that it reflects the body of the work. And then again, you also need to have an understanding that how your title will be found, because nowadays, if you have a very long title, it's difficult to find using a search engine, right? If you have a very long title, it's not going to appear in the search results. And consequently, if you have a title that's not appearing in the search engines, the chances of your article being found and being cited are reduced. So always have a very small title that reflects, the true essence of your work. And when you are framing a title, you need to ask all these questions. What is being presented in your manuscript? What information is going to be interest to your audience? So an example, if you're writing a manuscript that is going to be submitted in a journal for biochemists or a physical chemist, you cannot have like things that are related to different aspects like engineering or environment. You need to focus on the core audience, right? So you need to define a title that appears to the audience of the manuscript in which you are submitting, the journal in which you are submitting. Additional questions like what details need to be made clear in the title. So not everything needs to go into the title. You can skip some points. You can keep them in the graphical abstract or in the abstract. What are some of the features that are going to catch attention? So when you're writing a title, you also need to have an understanding that there are some aspects that need to be highlighted in the title. Like maybe if you have designed a material that's very eco-friendly, very cost-effective, so that needs to go there. Or you have designed a material that's very easy to synthesize, you can put all those things there. And finally, you also need to have an understanding that what are some of the key descriptive terms that need to go. If you have done a study on computational chemistry, you need to put it there. Or if you have done a work that's related to something that's related to environment, you can put it there. So when you're drafting a title, you need to have an understanding that these are some of the key questions that you need to ask. So there are questions that remain that, what type of a title hits the right type for target, right? And there are two titles before you. Title one, synthesis, electrochemistry, spectroscopic characterization, and X-ray crystal structure of a novel NACNAC LA complex that attacks DNA and cures cancer, right? And there's a different title, a certain complex that cleaves DNA at nanomolar concentrations. So which of these two titles do you think is more effective for you, or tells, the right story in a smaller way? So you can see the title one and title two, they're trying to communicate the very same thing, but title one has a lot of data. It's not essential because, of course, you did synthesis and you performed characterization to come up to a complex, right? And that complex attacks DNA. That's an application. But curing cancer, that's, too widespread. You cannot, claim that your complex is curing cancer based on just an experimental study. It's going to take a lot of effort. So title 2 is a better reflection because you came up with the complex. Of course, it goes without saying that there was synthesis and characterization involved. And what is that complex doing? It's cleaving DNA at nanomolar concentrations. So any person who is familiar with the work of DNA, cancer drug design will understand that yes, this material can go ahead and it can be utilized for cancer treatment. So you can see that a smaller title attracts potential audience, is easier to find, is easier to retrieve, and it's also easier to index. So your paper will be found by more people, it will be read by more people, it will be cited by more people, and consequently your citations will also go up. Goes without saying that your content of your title needs to be simple, effective, and also accurate. So if you look at the first title, the authors have made a claim that it cures cancer. It may or it may not cure cancer. But who are you to claim in your title that I'm doing this to do that? It's a potentially hard to justify claim. And good authors avoid that. So where do you get to know all these type of right titles? So even if you don't have access to ACES publications, there are a lot of journal articles that are selected by ACES editors as ACES editor's choice, and you can go and read them. They are freely available, and these manuscripts are all good quality. And the best part is that the editors have sat and looked at it, and they say that these are some of the best manuscripts of that field. So you can go read them. They tell you how to come up with a good quality title. They tell you how a good quality manuscript is written, how some of the good quality graphics are designed. And the best part is that all these manuscripts, they keep shuffling. And if you don't find a manuscript related to a field, trust me, sooner or later, there would be a manuscript that you'll be finding that is going to be relevant to your work. Next, we come to a graphical abstract. And a graphical abstract is the second thing that you look at your manuscript, right? Just like a movie has a title and a poster. So there's a graphical abstract also, right? And the graphical abstract is typically one of the first images that any potential reader is going to look at it. So what does a graphical abstract do? A graphical abstract provides you a snapshot of your research findings, and it is a welcome mat for the readers. So if you have a good quality abstract, graphical abstract that shows out that these are some of the works that have been done in the manuscript, it is going to bring a lot more people to your paper. A good POC or a good graphical abstract must resonate with the title. So the title is there and the graphical abstract is there, they should complement each other. And sometimes it's also an opportunity for you that if you have missed out some of the key facets of your manuscript in the title, you can include that in the graphical abstract and they complement each other. Second thing, a graphical abstract also provides a reader with a sense of understanding of what is going to be presented in the manuscript. So when you're preparing a graphical abstract, you need to ensure that everything is designed in a simple yet easy to understand manner. And then again, a lot of people make the mistake of is that they cut and copy paste one of the images from their manuscript and they use it as a graphical abstract. Trust me, it's a wastage of your time because you're wasting an image, which image could have been used to convey a lot more information to the wider audience. So how do you design a good quality abstract? A good quality abstract should be designed in such a way that it reflects, the right type of experiments that have been done in the work, the right type of message that comes out of the manuscript. And if you want to understand that, how a good quality TOC is designed, you can check out this paper by in Chemistry of Materials. Its table of contents, images, science, and beauty is equal to clarity. In any TOC, you should avoid the use of cartoon images in excessive quantity because it does not look professional and it does not paint a very good picture. Additionally, you should also try to avoid any logos from universities, government associations, companies. So there are two TOCs here, TOC A and TOC B. If you want, you can put it in the chat that which one do you think is a good reflection of an ideal TOC. So you can see that in TOC A, the authors have shown a self-assembly that's taking place. And then again, they've also shown that a new complex has come up based on, the chain lengths and under MRI guided tumor targeting and using light. What it does, it provides a very precise release of drugs, improves efficacy of the drugs, and then again reduces toxicity. Similarly, in TOCB, the authors have designed a material that is reacting differently under different types of light. So which one do you think is a better TOC, TOCA or TOCB? You can put it in the chat if you want. So as you can see, TOCA is a good example, TOCB is not so good example because In TOCB, the authors have used a lot of cartoon images, and some of these cartoon images, they may not be copyrighted or proprietary material. So tomorrow, maybe somebody can come and say that, you don't need to use these images, they need to be removed, right? So always try to avoid doing that. Additionally, there's a different example, like here is a title, water soluble super paramagnetic magnetite nanoparticles with biocompatible coating for enhanced magnetic resonance imaging. And similarly, look at the TOC. They've shown that there's an iron complex, it's taking place, there is a nanomaterial range, a nanometer range. And then again, they've also tried to highlight, the biocompatible part by having like a green image. And they have shown, it's applied for MRI. So you can see here that the title and the TOC, they complement each other perfectly. And this is what, allows you to have like a good quality combination, that yes, the authors, even before, like the readers of a manuscript, even before reading the entire manuscript, know that what's going to happen. So they know that it's talking about water soluble complexes, biocompatible coating, and then again, they're going for MRI imaging. So this is the example of having a good quality graphical abstract and a title working together in tandem. Again, we have 4 different TOCs: TOC-A, TOC-B, TOC-C, and TOC-D. So which one do you think is a good example? If you look at TOC-A, TOC-A shows that there are several different materials that are, being selectively separated using a different complex, right? In TOC-B, the authors have copy pasted an image from, the results part, and they've put it there as a TOC. In TOC-C, they've tried to show something, but there is no underlying discussion that goes with it. And in TOC-D, again, the authors have combined a lot of data and put it across. So which one do you think is the right TOC? TOC-A is the right TOC because it communicates to the readers that, what the authors have done in the manuscript. Similarly, TOC-B and TOC-D are not considered to be good TOC because the authors have just compiled the data and put it there as it is without any accompanying discussion. TOC-C can be considered to be a TOC, but then again, there's no clarity on what the authors are trying to show. It may be something related to biological phenomena, it may be something related to material sciences, but there is no underlying discussion with it. So, as an editor or as a reviewer, which one do you think can be considered to be more attractive? TOC-A, right? The other TOCs, they won't sound good, right? While we wait, if you want, you can put in the questions and I can start with the abstract section, right? So we have covered, how to write a good title, and then again, how to have a good experimental abstract. Now we are going to come to an abstract. So what is an abstract? An abstract is a summary of the work that is going to be discussed in the manuscript. So in totality, it's a mini paper. An abstract is written in such a way that even if a person is not an expert in a field is able to understand, because this is going to be read by everybody, even an undergrad or a person who is going to be just starting the work in that field is going to read your abstract. So you need to write an abstract in such a way that people who have a bare functional knowledge of your field can also understand it. Again, similar to a title, in your abstract, you need to avoid the use of words like superb, excellent, exceptional, outstanding, because without numbers, these words make no context, right? They don't have any context. It's better to provide that, my material improved photocatalytic degradation by 6% or 7%. Just provide some numbers instead of writing excellent or superb or exceptional, right? So avoid the use of all these words. When you're writing an abstract, you also need to have this context again, that who are your audience, because here the audience is going to be the editor-in-chief, the readers of the manuscript, any other person who's going to be reading your manuscript. So it should be written in such a way that it appeals to them. Also important to understand where your title is, where your abstract is going to be posted, because the abstract is freely available. It is going to be read by everybody. So you need to write your abstract in such a way that, yes, it makes sense. And this is where it also important that you don't include any references or any other images there, because a title and an abstract, they are posted independently. So if you have any references that are put in the abstract without the wider paper, those references are not going to make any sense. So avoid using any references in the abstract section. Next question, how? So you need to have an understanding how your abstract will be discovered by other SEOs. So put in all the keywords there. So as I said, that if you're working in physical chemistry, if you're working in semiconductors, put all those things there. Then finally, we come to this question, what? So what is the purpose or end goal for your abstract? Your end goal is to get more people to be interested in your manuscript, get them to read it, so it should be written in such a way. One thing in your abstract that's very important, that how your work is important for science, or how is it important for the people. Why should people care about your work? So a couple of lines in your abstract should always reflect that yes, your abstract is solving a certain problem that's going to be very beneficial, very helpful to a lot of people. So I'm going to give you an example that how a good quality abstract is written. So here, if you look at the abstract, the optimization of PROTAC ternary complex using DNA encoded library approach. So in the first two lines, you can see that the authors have briefly stated what is the problem and the purpose of the research. In the next couple of lines, what they have done is they have provided a couple of sentences that indicate the methodology, or the experimental pathway they took to come up with the findings of the study, and what are the key findings of the work. After that, they have written in just a couple of lines that whatever the conclusions they drew from the findings of this work, and finally, what they have done, they've ended with a sentence that has summarized, the broader implication of the work. So I'll give you some time to read it, and we are going to come back to this. So hope you were able to take some time to read this abstract and able to draw more inferences from it. Similarly, if you look at this other abstract, in which the authors discover interface stability in solid state batteries. So you can look at it. In the first three lines, what they've done is they have provided a diagram that development of high conductivity solid state electrolytes of lithium-ion batteries has proceeded rapidly, but there are some challenges in operating new materials. Why are there challenges? Because the exact mechanisms of the resistance happening in those batteries is not fully understood. So what authors have done, they provided a line of methodology that they have developed a computation methodology to examine the thermodynamics of formation of resistance interfacial cases. In just the line that they have written the methodology, then they have pointed out the conclusions, that the conclusions have come up with certain type of findings. And after that, they have provided closing remarks that yes, our experimental values have led to our experimental results, or our experimental investigations have led to this, and this is how they move the field forward. So you can see that how the authors have just come up with this experiment, and they have come up with this information that makes a lot of sense. With this, we come to the next section, that how do you talk about abstract graphics, and because you have a lot of data, and it's really important that you put your data in such a way that it takes access to a lot of people. So when you draw graphics, you need to be mindful that the graphics are drawn in such a way that they are clear and precise. They should contain the data that tells your story. A lot of people, remove a lot of noise from the data, and then again removing that noise and cleaning that data, removing the essence of the data. So avoid that. You can also use a lot of other, because there are multiple lines going, there are multiple times going, there are multiple points going. So if you use color, it's easier to differentiate. It goes without saying that when you are using any graphics, they don't be original published work. When you experiment, you are taking it somewhere, when you provide the citation and the proper permissions for that. And finally, if you are reporting any experimental data that has a lot of analytical component, always try to do error analysis. Even if you are not able to provide error, but you provide discussion that is experimental performed with a machine data, and like detailed places of behind a point, or like places behind a point, and then again the standard deviation of the values is like a certain range. So when you're providing this data for the graphic, always start with these things. So when you are reporting a data in form of a graphic, you have like that data reported in such a way that they are clear and concise. Just simple but informative. So one look at the data, you know what's happening. So when you use a lot of colors, you use a lot of images that can be easily differentiated. It becomes easier for the readers and the reviewers to understand what is being talked about. It does not like strain your eyes to look at the data. And additionally, it goes without saying that your graphics should always complement that text. So what the data is being reported in the graphics always complement that what is the information that is coming out of what is the graphic, the data from a graphic should always be reflected in the text, and they should make a lot of synergy together. You cannot like pull in your text and have your data reflecting out there. Again, I'm going to emphasize this fact again because this is what a lot of people make the mistake. The graphics was the original unpublished work. Even if you have published your work previously and you're using that image there, you need to provide the citation there, and you need to provide you need to take permission to use that. So when you are drawing a graphic, just look at the image towards the left. You can see how the authors have clearly represented the data with having legends to identify what are the traces. They have visible minor and major text there that provide you how the data is being mapped out. They have a bold access line. They have vibrant colors that help people distinguish which is the data that's being presented. And when they have written the access title, they have put it in a bold so people know that what's being talked about. So you can see that it's an absorption value of a UVP. It's easier to read, right? And then again, if there is something that has less clarity, they have provided an inset, and then where that data has been discussed in more detail. So towards the right, if you look at data A and data B, there are two types of data. So data A, the representation format data A, the authors are very clearly shown that what's happening. And in data B, you can see that the authors have not been able to make a clear image. And while their data may be very promising, but the images are not clear, and somehow if the reviewers don't feel like making a manuscript ahead, they're going to reject it. So always a good practice that when you are preparing any type of graphics, avoid the use of excessive black and white images. You can use a lot of color because these or like any other peer societies, they do not charge for color images. You can use that, and you can use as many colors as possible. It's really a good practice. It helps people differentiate what are the images being presented. Additionally, once you prepared the graphics, when you are preparing the PDF, you need to have an understanding that those graphics are in the right place. I've seen a lot of manuscripts while reviewing that the authors have done a lot of good quality work, but when they have copy pasted those images into the file, somehow they don't reflect. And while preparing the PDF, it does not appear. So it is a wastage of your work. Even if the editor-in-chief comes back to you and gives you a chance to correct your manuscript, it's going to be a loss of time on your part. So once you have pasted an image into your manuscript and you have prepared a PDF, just go back, have a look that yes, all those images are appearing in the right way and in the right format or not. After your manuscript is ready and you're ready to submit, you need to have a cover letter. And cover letter is very important. A lot of people make the mistake that cover letter they prepare it on the go. But cover letter is your first chance to have a dialogue with the editor-in-chief and the associate editor who are going to be handling your manuscript. When you're writing a cover letter, you need to have this justification that why that cover letter is appropriate, why your manuscript is appropriate for that journal. And if you have a good quality cover letter, trust me, the editor-in-chief is going to know that why that manuscript should go into that journal, why people should be interested to read your paper, why should people be interested to review your paper. So in a cover letter, you need to highlight what are some of your most important findings, what are the findings that are interest to the audience of that journal, because trust me, if you're writing to a journal that publishes in physical chemistry, people would be interested to know that how your manuscript is moving the discussion ahead in the field of physical chemistry. Additionally, you need to check the impact to the broader community. So if you have done some very good quality work, you need to highlight some of the data there that yes, your experimental results are very much beneficial to such and such field, such and such way. You need to put it all there. Additionally, while preparing an abstract, you don't need to copy paste the abstract and put it in the cover letter. Trust me, the abstract is already there. So you cannot copy paste the abstract and put it in the cover letter. It's not a good way of using the word. And finally, do not simply state that your manuscript is of interest to the field. Of course, every manuscript is of interest to the field. That is why the editor-in-chief is going to take a look at it. Be very specific, be categorical, because the EICs will spend a significant amount of time reviewing those manuscripts. And if you have the right communication there, they would be more than likely to be looking at your manuscript. They will be more than likely to send your manuscript out for peer review. So I'm going to give an example of how a good cover letter is drafted, and this cover letter was written by Professor Francis Arnold, a Nobel laureate, to another editor-in-chief, Professor Calvin Bertozzi, who's also a Nobel laureate. So you can see that, dear Professor Bertozzi, directly they have written that this is the name. So if you are confused that who do you address it to, just go to the journals page, find out who is the editor-in-chief, write their name. It shows that you have taken the time out to go to the journal page, and it always provides a personal touch. The next line, very simply, we wish to submit our manuscript, your manuscript title, to the journal name. And then they have highlighted, what are the main findings of the work, that yes, they did this and they obtained this. That's it, nothing more. So in just 2 lines, they have highlighted the core essence of the manuscript. And finally, in the next 2 lines, if you'll see that what they have done is they have highlighted that why this manuscript would be of interest to the readers of the journal ACS Central Science. A very simple TOC. And trust me, if you have a TOC like that, if you have like a cover letter written like that, people are going to be interested to review your manuscript. People would be interested to read your manuscript. I understand that this is all intimidating and it's a lot to soak in. Trust me, it took a lot of effort on my time also. But then again, if you need additional help with those resources, there is a free resource that's available for you known as ACS Author Lab. And ACS Author Lab provides you step-by-step guidance on how to write a manuscript, how to review a manuscript, right from selecting the right type of journal, how to prepare a good quality abstract, how to prepare a good quality image, how to prepare your manuscript for review, what to write in a review, all those things over 8 different steps. Even there is one step that is categorically dedicated to ethics and plagiarism. So how do you need to obtain the right references? How do you need to obtain the right permissions for your manuscript? It's all there. And the best part, once you complete that, you get a certificate from ACS showing that, yes, you have completed ACS Author Lab. It's a very small course. It's not going to take a lot of time. And once you complete, trust me, you are going to benefit a lot from the observations and the findings there. And there are some additional key resources available at ACS that help you, publish your manuscript in like a good quality journal. They can be found at publish.acs.org. You can go there, you can publish. You can find a lot of these research resources, including, ACS Guide to Scholarly Communication. It's very important because publishing as a field is rapidly evolving. There are a lot of things that are coming up. And once you look at it, trust me, it's going to be very beneficial when you're writing a manuscript. Now let's come to a very important question. How do you choose the right journal? Trust me, a question that has come to a lot of people. A lot of people say that, you choose a journal by the impact factor. You start with a high impact factor, keep going down. But no, that's not the right approach. You need to choose a journal based on what aligns the best from your manuscript. You have written your manuscript, you are the best judge for that. So when you have written a manuscript, try to have an understanding what type of a paper it is. Is it a fundamental paper or is it an application-based paper? Is it a paper that allows you to have a better understanding of the core classics, or is it something that is going to advance the applied fields forward? So based on that, try to identify a journal that aligns with the work. So I'm going to give an example. Like there is a journal known as ACS Applied Materials Interfaces, and it accepts a paper that talks about new material synthesis, fabrication insights. That's it. Studies that use existing or commercially available materials are not encouraged. So you can see what they've done. They talk about categorically new materials and not commercially available materials that have been synthesized beforehand. Second thing, and it's also written in red, ACS Applied Materials and Interfaces is highly application focused. So if you have a manuscript that is going to talk about a lot of applications or it talks about a certain application in detail, ACS AMI is going to be a home for that. If you have a manuscript that talks about fundamental applications or fundamental Investigations, trust me, AMI, it's not going to go into AMI because that's not the nature of AMI. So if you're confused that what a journal is going to accept, you can always go and check out the journal homepage. There is a wide journal scope written there. You need to keep reading the scope again and again because trust me, these journal scopes are revised on a regular basis. Additionally, you need to have a very good understanding of the author guidelines because a lot of the journals, not only ACS, but a lot of the journals, they take plagiarism very seriously. And if your manuscript is plagiarized, if you copy pasted materials from your own manuscript and you put it here, it does not constitute a good practice. And a lot of the publishing houses, they use various tools like Authenticate or Turnitin, to validate, what are some of the text overlaps, and they're going to come back to you and they're going to say that, replace this text. So always avoid having these type of things. You have written a manuscript, now you want to review a manuscript. And if you want to review for ACES publications, there's also a path available for you. You can just go check out ACES Reviewer Lab. It's free of cost. And the best part of ACES Reviewer Lab is that it teaches you how to do an effective peer review. So over six very easy to understand sections that introduce you to peer review. What are the ethics in peer review? How do you prepare a good quality review? What do you look for when you're looking at a manuscript? How do you assess its significance and its technical quality? How do you assess publications readiness for publication? And how do you avoid biases? So it's all taught to you in the ACES Reviewer Lab. When you're writing a manuscript, when you are reviewing a manuscript, there are a lot of biases that you may face. Like there would be ethical or gender bias or geography bias or prestige bias or model bias or positive bias. So science is something that allows you to negate all those biases. Always try to have a clear understanding that you are reviewing the manuscript for its scientific content and scientific content only. You need to avoid considering any of those biases. And if you face that, if you think that there are any confusions related to it, always communicate to the editor-in-chief. They're more than ready to help you out. So what you get from ACES Reviewer Lab, you get a lot of understanding of how you read a manuscript, how do you review a manuscript, and the best part, it's taught to you in a very easy way. So if you want to know that how do you review a manuscript effectively, go check out ACES Reviewer Lab. It's a very effective tool. And as I said, similar to ACES Author Lab, once you complete ACES Reviewer Lab, you also get a certificate for doing that. So I'll take a brief pause, and if you have any questions, just feel free to put it in the chat box, or you can raise your hand. I'll be happy to answer any of those questions, and then I can go to resources at ACS. Any questions? Okay, so I'll come back to the questions later. First, we can cover resources at ACS. So one of the first things that you need to access ACES resources is that you need to have an ACES ID. It's free to create. You can just go on Paragon Plus and you can create an ACES ID for you. However, with ACES resources, you have the tremendous possibility to discover a lot of resources that you can read CNN publications. That's one of the go-to public news that is available here. You can also go discover various opportunities to advance your career, and you can share your work. You can connect with other scientific professionals. So one of the best things that is about ACES publication that a lot of people know is that you have ACES journals that are widely published. There are more than 80 journals available till date. And one of the first journals that was published by ACS was the Journal of American Chemical Society. It was published since 1879. Let's cover a vast range of resources, ranging from applied research to core classics to environment and sustainability. There are also several domain-specific journals. So if you're interested, you can check them out. They are available at pubs.aces.org. Additionally, if you don't have subscription to ACES publications, you can also check out the various open access articles available at ACES at a microsite that's available here. And the best part is that all the journal papers that you're going to find here would be open to you anywhere in the world. You can download it, you can read them, you can share them as per your convenience. So as I talked about ACES Author Lab, it's a free resource. If you want to learn about manuscript writing, you can go and check it out. You get a certificate for completing that. Now, this is something very interesting, the ACES Guide to Scholarly Communication. So over a period of time, like on a regular basis, several industry professionals, academicians, and librarians, they sit together and they try to analyze that where the publishing world is evolving. And they come up with this ACES Guide to Scholarly Communication. It's regularly revised, and what it does is provides you a lot of information on how do you write a good quality manuscript, how do you come up with factors that are going to make your manuscript more publication ready, more likely to be published. Additionally, one of the key things that are currently very much in popular is that can you use AI to publish your work, or can you use AI as a author? Trust me, for ACES publications and other publication houses, the use of AI does not qualify for authorship. So you may use AI for text editing, you may use AI for grammar checks or everything, but you cannot list an AI as a co-author. So avoid doing all of that. It's mandated by COPE. So avoid doing that. If you want to have an understanding of what are some of the ACES events coming up, you can always visit out the ACES International India page. And one thing that I would like to highlight is that ACES organize a lot of very good quality talks every week. This is known as the ACES Science Talks. We have a science talk almost every week, and these are scientific talks by specialists on a specialized topic for a specialized audience. And these are eminent scientists from all over the world. If you have missed a science talk, don't worry. There are resources available for you on YouTube. You can just go type ACES Science Talks. It's freely available. Additionally, we have launched a very new course for UG and PG students and PhD students to enhance the job readiness. It's called the Virtual Internship Capsule. So you have in the Virtual Internship Capsule, you have on-demand learning and development. You have networking and doubt clearing sessions. There are weekly open houses for discussion. There are live interactions with the course mentors. And the best part, you get a certificate on completing that. These are some of the current modules. So if you're interested to know about Virtual Internship Capsule, you can reach out to me. I'll be more than happy to share additional insights. And currently, I'm very happy to share that we have a cohort of more than 50 students from US completing a Virtual Internship Capsule on CCUS. And these are some of the snapshots from the module. So you have a lot of technical reading, you have a lot of video lectures, you need to do a lot of quizzes, you need to prepare an end of internship report. And based on that, you get a certificate. Additionally, there is also an opportunity for you to interact with your cohort, write questions, reach out to them, and they'll be more than happy to help out. If you want to present your work to a global audience, we also organize a lot of ACES meetings. They're held twice a year in spring and in fall, and they are a gathering of more than 20,000 scientists and chemists in one place. So if you're interested, you can just reach out to us. We'll be more than happy to help you identify what are some of the suitable tracks in which you can submit your work. You can see that a lot of people go there. These are pretty top-notch people. They are, Nobel laureates. They are ACES fellows. They are some of the very best people in chemical and chemical engineering spaces. Additionally, if you don't think that you can attend ACES meetings, or if you currently lack the resources to attend an ACES meeting in the US, you don't need to worry. There are a lot of resources available for you to attend an ACES meetings in the hybrid mode. They allow you to attend ACES meetings from anywhere in the world. And this is known as the Global Virtual Symposia. It's a fully virtual programming. You can attend it from anywhere in the world. You can do it from your lab, your home, from the comfort of any place. And the best part is that there are multiple different symposia that are available for you, from organic chemistry, inorganic chemistry, medicinal chemistry, environmental chemistry. All those things are available for you. These sessions, they have been developed in collaboration with global partners. A lot of people, they have put in their efforts to develop it. And the best part is that you don't need to get up in the night to present your work. These sessions are designed in such a way that you have your sessions in your own time zone. So trust me, if you are presenting from Thailand, you'll have your presentation somewhere in the vicinity of your this time. You don't have to get up in the midnight to present your work. So they're designed in such a way. Additionally, I encourage you to apply for various ACES awards. So if you're working in the field of chemical and spectroscopic method for biological phenomena, we have the Nakashi Prize, that's $5,000. If you're trying to attend a professional meeting, you can attend the ACES Student Communities Grant. There are professional development grant. If you want to organize some chemistry outreach, you can apply for the ACS Chemistry Festival grant. If you're trying to organize an event at your institute, you have the Global Innovation Grant. So multiple opportunities are available for you to work with ACS. I welcome you to connect with ACS. We are quite active on LinkedIn, Instagram, Facebook. Wherever you are convenient, just feel free to reach out to us. Thank you. If there are any questions, I'll be taking them now.
Hi, may I ask some question about the
Yes,
grant
yes.
that you just talked about? Do students need to be a ACS member?
No, Professor Yutana, the best part is that for most of our grants, it does not matter if you're a member or you're not a member. They are member agnostic because they have been put in place in such a way. So I'll give you an example. If you're working in the field of physical chemistry,
Yep.
it does not matter that you're an ACS member or not. If you're attending a certain event and you want support for that, they are going to just judge your work on the merit of what you have submitted, nothing else.
Okay. And the application is like open year round, or there's a specific deadline for it?
So most of the applications, they're opened year round, but yes, if you're applying for travel grants, they are open closer to the event happening.
Okay.
So like if the event is happening in March, the travel grant is going to open in December.
Okay. Thank you.
Thank you. I can see there are two questions. Is it acceptable to check whether this manuscript is generated using AI? So yes, that's possible because AI has a certain way of writing the manuscript. Trust me, if a person has experience with writing manuscripts using AI and then again writing manuscripts by themselves, it's very easy to find out. But it's not a bad thing that you have used AI to perform grammar corrections or text corrections in your work. So that's allowed. You can use AI to do that. The only thing is that you need to mention in the acknowledgement section that yes, this manuscript was corrected or this manuscript was, grammatically checked by a certain AI. That's totally allowed. You can do that. But you cannot put AI as a co-author in your manuscript. That is not allowed. Hope that is okay. Any other questions? Additionally, if you want, like maybe there is an opportunity here. So if you are interested in knowing more about some of the type of chemistry that is happening worldwide, you can reach out to us. We'll be more than happy to organize a specific uh, invite-only scientist event for that also. That is something that we'll try to do very soon. Uh, Additionally, if there are any more things that you want to know from me, I'll be more than happy to help out. So, Dr. Thana, I think we are not having any more questions. If there are no more questions, I believe we can go ahead and close this session.
Can I ask one last question?
Sure. Like I still have 35 more minutes for this session, so you can ask as many questions for that.
Okay. You mentioned about the internship capsule, the
Yes.
virtual internship capsule. That's also like available or eligible for Thai student too, right?
Yes.
Or
Yes.
so anyone can apply for it or can register for it.
Yes. So the currently what we have designed for the virtual internship capsule is that we are designing courses that are going to be relevant to industries in specific part of the world. So what we are going to do is we are going to send out the information. If your students are interested, we'll be more than happy to arrange a virtual internship capsule for your students. In doing that, we'll also try to speak to some of the industries in Thailand and ask them to come do like a session so students also know and get an opportunity to ask from them that what do they look for in students when they are hiring them. And maybe there's also a possibility to pick up students for like maybe jobs or internship.
Okay.
So we have done this currently in India, Nigeria, Thailand. We have done this currently in India, Nigeria, Ghana, and USA.
Oh,
And
okay. Okay. So if there's no more question, then I would like to thank Dr. Krishna again for the wonderful webinar, and I hope that we will have some more meeting or interaction soon. Okay, so thank you very much and bye bye.
Thank you, Dr. Yutana, for your time, and thank you everyone for turning up. Looking
Okay.
forward to more interactions. Bye bye.
Okay, goodbye.